Hi, we have the last question of the exercise 7, which asks us to um, write several square numbers as a product of prime factors using index notation. The second part of the question says what is true about the index needed for each prime that we will have. So we will take a start with the first part of the question, which asks us to write several square numbers. We know by now, as we have solved different questions in our previous exercises, in previous videos on square numbers, where we defined them to be the whole number multiplied by itself. So 2 square, 2 is a whole number. When it is squared, it gives us a square number. 3 square, 3 is getting multiplied with itself, giving us a square number. 4 multiplied by itself, 4 is a whole number, multiplied by itself give us a square number. 5 is a whole number. When multiplied by itself, it gives us a whole number. The same is with the rest of the numbers. 6 square, 6 is a whole number. When multiplied with itself, it gives us a square number. 7 is a whole number. When multiplied with itself, gives us a square number. 8 is a whole number. When multiplied with itself, give us a square number. 10, in the same way, it is a whole number. When multiplied by itself, gives us a square number. And so is 12. It is a whole number. When multiplied by itself, it gives us a square number. So then we are asked to write them as a product of prime factors. In the previous exercises, we also have solved how to write a number as a product of prime factors. So let's say if it's 4, the square number, how to write it as a product of prime factor. In here I have mentioned it. 2 multiplied by 2. The prime factors are written in multiplication with each other. For some of the numbers, square numbers, I have mentioned them, how can we find their prime factors using the tree diagram method. As you can see, for the 4 or 5 of the numbers, square numbers in here enlisted, I have used the tree diagram to find their prime factors. 3 is a prime number, 7, 5, 2, so all of them we were able to use a tree diagram method. I have not done it for all because we have already practiced it in the previous question, so it would be a repetition. However, about the product of prime factor, to express each square number as product of prime factor, I have expressed it in here. 16 can be expressed as product of prime factor as 2 multiplied by 2 multiplied by 2 multiplied by 2. 25 can be written as 5 multiplied by 5. 36 can be written as 2 multiplied by 2 multiplied by 3 multiplied by 3. 49 can be written as 7 multiplied by 7. 64 can be written as 2 multiplied by 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 2. The same would be for 100 and 144 as well. So then, once we have expressed the square number as product of prime factors, the next is we have to express it using the index notation. So this prime factors should be expressed as index in the index notation. So 2 multiplied by 2, we can write it in index notation as 2 base, and the index would be 2 because 2 is the number getting multiplied, and the number of times it multiplies, it is 2. The same is with this 3. For the square number of 9, 3 would be the base and the index would be 2. For the square number 16, we will write it 2 as the base and 4 as the index, looking at the product of prime factors in here expressed. For 25 square number, 5 multiplied by 5, this is the this number is written as product of prime factors. 36 is the same, 2 multiplied by 2 multiplied by 3 multiplied by 3. So in the index notation, it is 2 raised to the power of 2 and multiplied by 3 raised to the power of 2. The bases, the two different bases are expressed in multiplication and their index is mentioned. In here, 5 would be the base and the power would be 2. The same takes place for 49. We have expressed it in the product of prime factor. Then we would write it in the index notation, so it would be 7 with the index of 2. 64 would be base 2 and index 6. 100 would be base of 2 with index 4 multiplied by base 5 with index of 2. And 144 will be 2 base with index 4 multiplied by 3 base with index of 2. So now that we have solved the first part of the question, we will be moving towards the second part of the question. So the second part of the question, we have to understand it first, what it says in here. What is true about the index needed for each prime? So in here, index needed for each prime factor of a square number. That is what we have to identify. That is what the question asks us. That is the index that are used for each prime factor. What is required for square numbers. So in here, if we look into the indexes, we have 2, we have 4, as you can see, 2, 4, then we have 6. Yes, all of them are either 2, 4 or 6. So we can say that about the index needed for each prime factor of a square number, the index of every prime factor must be even, because these are even numbers, right? So the index or power of every prime factor is even number. What information does it give? That if every prime factor, in here as you can see, this is a prime factor, this is a prime factor, this is a prime factor, this is a prime factor. So if every prime factor has an even index, has the power that is an even number, the number is a square number. So with that, we get to know that if any prime factor has an even index, then we can deduce from that that the number is a square number. So this gives us a way to recognize square numbers from their prime factorization. If their prime factor has an even index, the number is a square number. That's all for this question. I hope the concept is clear. Thank you everyone. This is Math with Amina signing off. See you in the next video with an interesting exercise.